of chemical reactions. This is one of those topics I totally overlooked when I took this one in high school, because I just memorized these different generic names and what happens, but I never really understood what they meant. Well, when in chemistry, when you have reactants and they react to each other and they have to make a product, well, they have to make something. That something that you make is not some random things that just happen. Every time they react, you will get the same product. Well, how you get those same products? Well, they sort of follow these sort of types of reactions, or these blueprints or rules. And these 6 reactions that we're going to talk about, that's sort of the rules that the chemical reactants will react and will follow. So first 4 types. First one is your synthesis. Second is decomposition. You have single displacement and double displacement. I put them all out in this form because I want you to actually see that they're sort of in pairs. So the first one is synthesis. Synthesis is to make. So you have 2 basic things, 2 little things, and you make 1 big thing. Likewise with decomposition, this is completely opposite of synthesis, because you start with 1 gigantic thing and you break it into pieces. So there, remember that in pairs. So an example of this is, say you have magnesium and you react this with oxygen, O2. And what you're going to get is, since this is a synthesis, you're going to have them combine to each other and you form MgO. You must be wondering, why do I have MgO and not Mg2O or MgO2? Well, if you look at the charges, Mg is 2 plus, oxygen is 2 minus. Since this is 2 plus and 2 minus, the charges are balanced, so you get MgO as 1 single piece from these 2. Is the reaction, however, balanced? Well, let's check. You have 1 Mg, 1 Mg, 2 oxygen, 1 oxygen. So you need to put a 2 in front of here to balance that. But since you put a 2 here, well, you need to put a 2 here to balance the magnesium. So that's a synthesis reaction. Don't forget to balance your reaction after. Another example here is, let's say potassium is reacted with chlorine, and you're going to now get, or you're going to get KCl2 or KCl. Well, you're going to get KCl because if you look at the charges, potassium is 1 plus, chlorine is 1 minus. So you need this to equal to 0 because it's neutral. So since it's 1 and 1, they cancel, so you have KCl. Is the reaction, however, balanced? Well, I don't think so, because you have 2 chlorines here because of the subscript. You only have 1 chlorine here, so you have to put a 2 in front. So that means that 2 in front is 2 KCl's. By putting that 2, well, you have to put 2 here. So that's all balanced. That's the synthesis reaction. Jumping over to decomposition, that's a completely opposite. This is breaking down. So another example of this, say, let's say HGO. You have 1 big piece, and this is going to break it down into Hg and O. Is it going to be O? It's not going to be O, because O is a diatomic molecule. It needs to be by itself. So then now you're going to check, well, is my reaction balanced? It's not, because you can see that there's 1 oxygen here, 2 oxygen there. So you're going to put a 2 in front. That means that 2 is for this whole thing. You have 2 mercuries and 2 oxygens. So because you have 2 mercuries, you're going to put 2 mercuries there, and that is your decomposition reaction. And an example here, let's try MgCl2. This will decompose. Decomposes into magnesium and chlorine. Chlorine is another one of these diatomic molecules, so you need chlorine 2. So then you're going to check if it's balanced. It looks pretty good because there's 2 chlorines, 1 magnesium, 1 magnesium. So this is balanced, and we're all happy. Synthesis and decomposition. Now we're going to get into your single displacement and double displacement. Basically what single displacement is that you start off with 3 different pieces and 1 partner gets switched. So what that means is that this is the generic one. You have A plus B and C, and then you notice that the A basically took the place of the B. It displaced B. So to give you a real life example, let's see, we have copper and silver nitrate. So what products will you get? When you see these reactions, you should be able to see that all these ones are ionic compounds. That means that you can actually break it down into your anions and cations. So silver has a +1 charge, that's your cation, and nitrate is your -1, that's your anion. What happens is that, well, copper is going to be positive, it's a metal. So this has displaced your silver because the positive and the negative will attract to each other. The copper and silver can't combine because they're both positive, they'll just repel. So what you're going to get is that your silver is going to be your lonely friend that gets displaced by itself, and then plus copper NO3. And copper has a 2 plus charge, so we're going to put NO3 2 negative. So that's one example of a single displacement. Another example, let's use iron plus copper nitrate. So we're going to use sort of the reverse of this. And what are my products? Again, this is going to be split. So we can see that this has a 2 plus charge. Nitrate has a 1 minus charge, but because we have 2 of them, the total charge is 2 minus. You can see that this charge cancels out with this charge, right? Next step is single displacement. Let's move this out of the way. This iron is going to displace copper because iron is positive. So iron is going to take the place of copper. What happens to the copper? Well, copper is going to be by itself, and plus iron NO3. Is it going to be iron NO3? Well, this is going to be 2 plus, blue plus, and a nitrate is 1 minus, so you're going to need 2 of them. So you have iron nitrate in this form. So that's going to be your single displacement. Double displacement, let me see if I can change colors, is very similar, but now you have 4 different sort of ions. So an example of this is, let's try, not this one, let's go Fe, iron sulfide plus HCl. So you're putting iron sulfide in acid. You notice that iron and sulfide can be split into your cations and anions, likewise with your hydrochloric acid. So what's going to happen is that your cations are actually going to just switch places with each other. So H is going to go where Fe is. So H, S. Now notice that we have to balance the charges. Remember, hydrogen is 1 plus, sulfur is 2 minus. So that means that you need 2 hydrogens, so it would be H2S. Plus, now Fe has a 2 plus charge from this sulfur, and then your chlorine is 1 minus, so that means you need 2 chlorines. So this is your double displacement. After all this, then you have to double check that everything is balanced, because this is not balanced yet, because you have 2 hydrogens and you only have 1. So you're going to put 2 in here, 2 H's, 2 chlorines, 1 iron, 1 sulfur, 1 sulfur. So now this is good. So that's your double displacement. Let's try another example. KOH plus H2SO4. This is an acid and base neutralization reaction, but they actually will take place in a double displacement as well. So let me just kind of move this double displacement down here. And what we do is, same thing. This OH is a hydroxide, so we know that this is going to be 1 minus, potassium is 1 plus. H2SO4, H is your 1 plus, sulfate is 2 minus, so that's, we separate into your cations and anions. Next step is switch places with your cations. So this is going to be HOH, remember this is a 1 minus, this is 1 plus, plus KSO4, balance the charges. Potassium is 1 plus, sulfate is 2 minus, so you need 2 of these. So now all this is balanced, now we have to balance the entire reaction. So you have 2 potassiums, 1 potassium, I'm going to put 2 here. That means I have 2 oxygens here, and then 4 here, so that's 6 total oxygens. I only have 4 plus 1, so I need to put a 2 here. So now we just have to calculate the hydrogens. That's 1, 2, and then we have 2 of them, that's 4 hydrogens here. There's 2, 3, 4, that's 4 hydrogens here. So I think this reaction is balanced. So this, all this messy step, that's your double displacement, but this is also an acid and base reaction. So the next 2 is number 5, combustion. Combustion is basically using hydrocarbons and burning it with oxygen, and your products will always get CO2 and water. So your hydrocarbon is basically any carbon and hydrogen combined. So say you have CH4, if you burn this with oxygen, you'll get this. You just have to balance the reaction. You can have C2H6 plus oxygen, you'll still get this and water. Or sometimes you will get, say, what do I have here? C2H5OH. This is your ethanol, burn ethanol, you will still get CO2 plus water. Notice all my products are exactly the same because that's all the products of a combustion reaction. You're just burning hydrocarbons, and sometimes you can have oxygen there. Number 6 is your acid and base. This is acid and base reaction. So when you mix acid and base, you're going to neutralize. So one example is very easy one is acid is HCl plus NaOH. How you notice this is that in a base you will always have an hydroxide, and in acid you always will have just a single hydrogen. So what happens is this is exactly like a double displacement reaction. This H will switch places with the Na, so you get HOH, right? This takes place with the Na, so HOH, which is just water, plus NaCl, which is a salt. Salt is not always NaCl. It's one where you have your cations and ions, and it will usually precipitate up. Another example of this is, let's do CaOH, calcium hydroxide, plus what's a good acid? Let's do H2SO4. Again, double displacement reaction in an acid and base. It's just that this one you notice there's a hydroxide, OH, and there's an H here. This is sulfuric acid. The CAs will take place and switch places with the H, so you will get HOH, which is water. Okay, whoops, I totally moved the screen here. And then your next one is your calcium. Calcium is going to take place where the H is, so it's going to be CaSO4. Notice for your acid and base neutralization reaction, you always end up with water. This is going to be your H2O, and then you just have to balance your reaction after. And then this is still your salt, your cation and anion. That's your salt. So to recap all of these reactions: synthesis, basic, buildup. You form one big thing, decomposition, breakdown. One big thing and breaks it down into smaller pieces. Single displacement, you have 3 different things. So you have one by itself and one that is combined in an ion form. So you just switch the places with your cation. Double displacement, 1, 2, 3, 4 things, and just one cation switch. So your Fe and your H will switch in this case. Okay. Your products can vary. So this is, you don't just always get carbon dioxide or water or salt like in your acid and base. Oh, too far. And lastly, you can see this bar is moving. Okay, where am I? Combustion. Combustion, hydrocarbon, carbon and hydrogen with oxygen will always give you carbon dioxide and water. So this is all standard for combustion. And then the last thing is for your acid and base reaction. This is your neutralization. That means you're mixing acid and base together. Acid, base, water, salt. Always get water in a neutralization reaction. How do you know if it's a base? Hydroxide. How do you know it's an acid? H and something else. H and something else. Okay, this is the general part. Once we get into real acids and bases, and you're going to see there's different definitions, but this is just the basic 6 types of reactions, and you can use this to predict. So hopefully this has helped you in this lengthy video. So see you next time.